Hello, have you ever wanted to make a halo spin faster when you smile? No? Well, that's too bad because I just made a really late tutorial. Sorry for taking so long on this tutorial. You see a lot of stuff happen in my life and I just couldn't really handle it at the time. Keep in mind that this tutorial may be a little bit outdated by now. It's also kinda jank and kinda tedious to do. In order to achieve conditional loop physics, you're going to want to combine two main techniques. Number one is probably one you've seen a lot, mostly in tails wagging faster when you smile and other wagging physics. This is also known as conditional physics. In particular, I'm going to be using Blendshape weights to achieve this effect. I learned about this primarily from Soulty's tail resource file. You can go check it out on their Twitter. The second technique is looping animation physics. I found a tutorial on YouTube by the channel End, also known as Endcsline. Let's start off with the process. To begin with, we're going to set up a few parameters. I've listed them here. The first parameter is the speed switch. This will be linked to some form of expression or other toggle that you can use in order to trigger the effect. The next parameter is the slow speed parameter, however you can also substitute the breathing parameter for this. There's also the fast speed parameter, which you have to animate by hand. I like to default to making sure that it's twice as fast as the slow parameter. The fourth parameter is the slow loop. This parameter is the idle animation for the object. It's a blend shape and is set up as follows. The last one is the blend shape fast loop parameter. It's set up the same way as slow loop. Next, you're going to want to have two rotational deformers that are at the center of the shape. Ideally, you'd have it at dead center, but I kinda screwed up. I like to keep these rotational deformers separate from the base object because sometimes when they overlap in some way, they can cancel out each other's effects. For the slow rotational deformer, you're going to want to keyframe it at 3 points with a slow loop parameter. At -1, you're going to have it at -180 degrees, and at +1, you're going to have it at 180 degrees. Next, you're going to want to add keyframes at 0.1 increments for the rotational deformers. This is to ensure that they transfer over to the warp deformers properly. For the fast rotational deformer, you're going to want to do mostly the same thing, except instead of 180, you're going to use 360. Now you're going to want to add a blend weight rule for each one. The slow loop should only have an effect when speed switch is at 0. You can achieve this by making sure you use the step line. For the fast loop, you're going to want to do the opposite, making sure it only has effect when it's at 100. You can then put the base object within these rotational deformers as follows: fast rotation, slow rotation, and base object. This will enable us to preview the effect, but first we're going to have to make the animation. I have it set up as follows. While you can use the breathing parameter instead of the slow speed, I like to use the slow speed as it lets me control these things manually. For the fast speed, I like to keyframe it at twice the speed or more. An important step is now to make sure that these keyframes are set to linear. You can do so by highlighting it and then changing the object to linear. This just helps to make sure that the loop is a little bit more fluid. Now we're on to setting up the physics parameters for our halo. I have the slow physics set up exactly as follows. You can try to play around with the values, but I found that any time I tried, I ended up breaking the object. For the physics parameters, you're going to want to make sure that the output scale is as follows. For me, this number was 0.32, so maybe try that if you find your object isn't moving in a circle. Now here's my preset for the fast physics parameters. You can then play the idle animation that we had created earlier. As long as you have the physics blend shape rule set up correctly, it should act as the following. When the switch is at 0, it'll use its idle speed, but when it's at 1, it'll switch to the fast animation. I'm not entirely sure why, but the number values are pretty finicky, so while you can attempt to play around with some of these values, a lot of times it'll end up breaking the object. Once you confirm the effect is as you want it, you can then convert it into warp mesh deformers. Put a warp deformer within each rotational deformer, and then keyframe it exactly as before. Make sure that the blend shape weight rule still applies to these objects now that you have the warp deformers prepared. You're then going to want to select your rotational deformer and then apply it to the warp deformer inside of it. You go through this following menu to achieve that. As the object rotates in these new warp deformers, you're going to notice a little bit of jitteriness or shaking. In order to negate this, you're going to want to use extended interpolation on each of the parameters. I like to use ellipse with 2 points in between each keyframe. You can then preview the animation to make sure that it applied correctly and still works with the blend shape rule you made before. If the blend shape rule is gone, you just have to repeat that step onto these warp deformers. You can then put these objects into a large warp deformer so that way you can edit the shape as you need it. I keyframe the shape change so that way you can see the difference between them as they rotate. Now you can see the animation in effect with these warp deformers. Now you can import this file into VTube Studio. Just make sure that you have the following set up. The idle animation will be the one that we made beforehand. You're then going to want to make a parameter card for the speed switch. Feel free to set the input as anything you like. I have mine set as smile. As you can see, I like to have a very small difference in the input fields. That way, there's less jumping around and risk for error. Here's the finished Halo result. Thank you for watching this tutorial. I hope that it helped in some way, even though I don't know what I'm doing and this is probably not an efficient way of combining these techniques. Goodbye.